Hello friends, welcome into our new lecture on the performance of a Rankine cycle. In the last lecture we have seen what happens if you reduce the condenser pressure, and in which we have observed that the performance of a Rankine cycle increases with lowering the condenser pressure. Now similar to this, if you see what happens if you increase the boiler pressure or a steam what happens if you superheat the steam. So for that purpose we have drawn here or TS diagram of a Rankine cycle. So the reference cycle here is 1 2 3 4 1. This is our reference cycle. The point 1 temperature is increased from T1 to T1 dash, T1 to T1 dash. So what is the effect of this superheating of the steam on the performance of a Rankine cycle? So we are interested in that. So modified cycle now becomes 1 dash, 2 dash, 3, 4. This is the modified cycle. Now because of these modifications, the cycle area increases by this highlighted region. So this area, green colored area, is increased, which indicates that heat supplied increases, that is QS is increased. At the same time, the heat rejections area also increases. Which is the heat rejection area? That we can see the area below 2 to 3 process. This is the initial heat rejections for the reference cycle. This is the heat rejections, and the area increased by this green colored hatching, green colored zone or green colored area is increased, which indicates that heat rejections also increases. Heat rejection also increases in the condenser. If now which increase is more from this diagram, heat supply increase area is more as compared to the heat rejection area. Therefore, the performance of a Rankine cycle, that is 1 minus QR upon QS, in which QS is also increasing, QR is also increasing, but the heat supply increase is more as compared to the heat rejections. Therefore, the performance of a Rankine cycle increases. So this is one advantage we are getting, that by superheating the steam, we are getting more performance in the Rankine cycle. Then second advantage, if you see the dryness fractions at the exit of the turbine. So that is X2. This is the dryness fractions for the reference cycle, and X2 dash is the dryness fractions or the quality of a steam for modified cycle. Now here X2 dash is greater than X2, that is dryness fractions at the exit of the turbine after superheating of the steam is more, means moisture content at the last states in the turbine is more. So this is another advantage we are getting by superheating of the steam. So two advantage we are getting. One is performance, that is thermal efficiency of cycle increases, and second, dryness fractions at the last stages of the turbine, which is also increasing. These two advantage we are getting, and because of that in many thermal power plant superheating of the steam is done. So these advantages we are getting in the superheating of the steams. So in the next video we are going to study what is the effect of increasing the boiler pressure. Now here we can fix the maximum temperature of a superheating. How? As in this case we are getting, as we are increasing the temperature T1 as maximum as possible, so that we are getting the maximum Rankine cycle efficiency. But there is a limitations for this T1. For this T1, what is that limitations? These limitations or the maximum temperature limit depends upon the properties of the material or from metallurgical consideration. As this operating temperature is very high, the thermal stresses are developed in the material, and there should be some limits for these thermal stresses, and because of this metallurgical considerations, this maximum temperature is about 650 degrees Celsius, and beyond that we cannot increase the steam temperature. So like there is a lower temperature limit for the thermal power plant because of the atmospheric temperature limits and or the surrounding temperature limits. Similarly, for higher temperature there is a limit from the metallurgical considerations. And in the next video we are going to study, by keeping this maximum temperature limits, if you increase the boiler pressure, what happens to the performance of a Rankine cycle. So thank you.